So let's get into it. So the first thing that we spoke about within this course was the theorem of Pythagoras. And so that's the first thing we're just going to sort of practice for ourselves here. Now, does anyone remember, or does anyone want to tell me what the theorem of Pythagoras is? Like, how do I use Pythagoras? What is the formula? Pythagoras. I think that's how you spell his name. Amatle, do you want to tell us?
Hello, ma'am.
Hi.
So the theorem of Pythagoras is finding a side of the hypotenuse using addition or subtraction and square root. Yes. And ma'am, can I answer this question?
Okay, cool. Just hang on 2 seconds. Let me just write down the theorem. So guys, as Amatle has said, the theorem of Pythagoras revolves around the hypotenuse. And so basically it's the hypotenuse squared is equal to the sum of the square of the two other sides. So side A squared plus side B squared. Amatle also mentioned, I can't speak English, that sometimes we will have to subtract, and that will be the case when we're not solving for the hypotenuse, when we're solving for one of the other sides, which we'll look at in a second. And remember that we always want just the side length. We don't want the side length squared. And that's why Amatle also said this involves square rooting. Okay, so Amatle, walk us through how we would do this first question.
Okay, so ma'am, you would, since we don't know the hypotenuse, we would have to square root. I mean, for 16 and 30, oh my gosh. Yeah. For 16 and 30, we have to square the numbers.
Good. Okay, so we've got the hypotenuse squared is equal to the 16 squared is a plus the 13 squared. Hey.
Yes, ma'am.
Good.
And then when sorry, ma'am, we will get 256 squared plus 900.
Good.
And then we add that together.
Excellent.
Which will give us an answer of 1,156.
Perfect.
And then when I don't know what to call I don't know what to call this. I think
well, what do you want to do? Excellent. Good. Well done. We square root.
And then we will get an answer of 12,48.
Did you square root 1,156?
Sorry, ma'am. 34.
Yes, perfect. And what is the units of that measurement? It would help if these were in the same units there.
Millimeters.
Perfect. Well done, Amatle.
Thank you, ma'am.
Excellent. Okay, so guys, that is essentially how we do Pythagoras. So what we did was we used our theorem that said the hypotenuse squared. And just as a reminder, the hypotenuse is always opposite to your right angles. So this side AC is your hypotenuse. That was the X side. So there's my hypotenuse squared is equal to the sum of the square of the two other sides. Now my two other sides are BC, which is the 16 squared, as well as the side AB or BA, which was the 30 squared. And that is what the theorem of Pythagoras says to us. If I take the two other sides, square them, and then add them together, I will get the hypotenuse squared. Again, we don't actually want the hypotenuse squared, we want the hypotenuse. So we have to square root our value in order to get just the hypotenuse's length. But essentially, if we follow our theorem of Pythagoras, we will be able to get any length within our right angle triangle. Okay, so I'll leave that up there if you want to take a screenshot, but then we're going to try another one that's a slightly different. Well, you're going to try another one that's slightly different. And then we'll go from there. Okay, so what I'm going to do is I'm going to leave it up like that, just so that you can still see the theorem and you can see how we did question A. But what I want you to remember in question B is that the side I'm wanting you to find, so in this case, the x is no longer the hypotenuse. In this case, the hypotenuse is 35. So I have given you the hypotenuse in this case. I want you to work out the length of x. So give it a try, see what you come up with. If anyone's feeling brave and wants to put their hand up, they can. But I'm going to give you a minute or two to give it a try, and then we will have a look. Remember your units, because it is a length, so we do need to have units with our answer. And remember to square root. We don't want x squared, we just want x. And remember, if and when you're ready, you can put your answer in the chat, or you can raise your hand if you feel like you'd like to explain it to us. Give you another minute or so. Okay, Tandor, do you want to give it a try for us?
Yes, ma'am, I would like to.
Okay.
Okay. So as we all know that the hypotenuse is 35 centimeters. So we're gonna write 35 centimeters squared.
Good.
Equals x squared
Perfect.
plus 21 centimeters squared.
Perfect.
So now we're gonna find the so now we're gonna okay so now it's for the 35 centimeters squared, it is 1225
Perfect.
equals x squared plus 441.
Perfect.
And now we want 444 to go to the number on the left hand side. So we're gonna minus it with 1225 on
Excellent.
the right hand side and the left hand side.
Good. Are you happy that on the right I just write x squared?
Okay, ma'am, no problem.
Cool.
Then we get an on when we're gonna subtract 1225 minus 441 is gonna end up as 784.
Good.
And then we're gonna square root the 784.
Perfect.
Which leaves us with an answer of 28 equals x.
Perfect. And what is it? 28. What are your units?
Centimeters.
Excellent. Well, just
Or is it-
centimeters.
Oh, okay.
Area.
Okay, ma'am.
Good. Well done, Tandor. Okay, guys. So that is essentially how we go about getting our answer. Because we knew the hypotenuse, as Amatle had said in the chat, we know the hypotenuse. The second we know the hypotenuse, what's going to end up happening is the subtraction step over here. We're going to have to subtract this one side squared from the hypotenuse squared. And then it's very similar. We need to square root and we can get our answer. Okay. So simple, I'm not 100% sure if I know what you mean. If you mean the other way, as in 28 centimeters equals X, that's absolutely fine. But you do need to do the subtraction step in the second step over here. So as long as you did subtract somewhere, that's okay. And if you mean it's just 28 minus, 28 equals X rather than 20 X equals 28, that is absolutely fine. Ukanyo, do you have a question? Okay. The symbol, okay, so we can't do the first, no, English. We can't do it the same way as we did in the first one, because in the first one, the hypotenuse was unknown. That was the side I didn't know. In this question, I did know the hypotenuse. And so it needed to look a little bit different. So, excuse me. What I'll do is I will explain it sort of right from the start again. So if we go back to what Pythagoras says, it says the hypotenuse squared is equal to the sum of the square of the two other sides. Okay, that's the theorem of Pythagoras. So if we go to our diagram, this 35 centimeters is my hypotenuse. And then I've got my two other sides. It doesn't really matter which side is which. That was weird. Let's call this side A and let's call this side B. So if I now go and substitute in the values that I know, as we can see, we know the hypotenuse is 35 centimeters. So I'm going to substitute that in for H, 35, and that needs to be squared. So that's the first one. I'm just going to color coordinate as we go along. So that's the hypotenuse. The next side that I know, or the next side that I want the length of, is side A. So side A I've labeled as X. And remember, I want that squared. So that's my green side over here. If you want to say BC, that's absolutely fine. It's all essentially meaning the same thing. And then finally, we want side B, which is the side up at the top, which is 21 centimeters. And so I've got plus 21 squared. So those are all three of my sides. And like I say, it does need to look a little bit different to the first one, because in this one, I knew the hypotenuse. In the first one, I did not know the hypotenuse. So it is going to be a little bit different. Now, if we think about what each of these values sort of is as a number, if we type 35 squared on our calculator, we get the 1,225. X squared is X squared. And 21 squared is 441. Now, if I think about this in terms of an equation, which this is, I know that in order to solve my equation, I essentially want to take this positive 144 and put it with its like term and put it on the left-hand side. Now, because this is a plus 144, I know that I need to do the inverse operation and subtract 141. I'm saying a lot of weird numbers here. 441, sorry. So using my inverse operations, I subtract 441 on both sides, because that will then leave me with X squared on the left. No, not on the left, on the right. I don't know my left from my right. I do apologize. And if we now say 1,225 minus 441, we get 784 equals X squared. So far we're on the right track. I don't want the squared there, so I need to square root both sides, because that will get rid of my squared. And if I square root 784, I get 28 centimeters, which is equal to the length X that I was missing. So importantly here, because I knew the hypotenuse in this case, my operations were a little bit different in that I subtracted the two sides. If I want to work out the hypotenuse, like I did in question A, that's when I add them. But because of Pythagoras' formula, and because it is essentially an equation, we can sort of solve for any of the three sides, because I can always use inverse operations to solve for my unknown. I hope that makes sense for everyone. If not, you are obviously welcome to either send me a message or Yolanda a message and ask, or put it on the chat. Again, I'll leave this up in case you want to take a screenshot, and then we're going to have a look at our next question. Alrighty. Hope we all got that. Let's have a look. So the next concept that we spoke about was perimeter. So can anyone just remind me, you can raise your hand or I'll put it in the chat. What is perimeter? So I've said perimeter / circumference, but what is perimeter? Sifle, do you want to tell us?
Ma'am, you said perimeter was the total distance around a shape.
Perfect, exactly. So perimeter, exactly as Sifle said, is the distance or the total distance around a shape. So I always think of it as, if this shape is a garden and I want to put a fence around it, how much fence do I need? We don't need to think about it like that. For whatever reason, it just makes sense in my head to think about perimeter like that. But essentially it is the total distance around a shape. So if we look at this first question and I'm asking you to determine the perimeter, firstly, we want to know what shape I'm working with. So in this case, this is half a circle or a semicircle. And the perimeter is essentially that yellow outline. I've already thrown a hard one here to start off with, but anywho. If we want to work out the outside length, essentially what I need is the length of this curved edge, as well as the straight length at the bottom. Because if I combine the straight length with the curved length, I get this hemisphere or semicircle. Now, what we need to remember is that when we are working with circles, we've got quite a few formulas that we need to remember. So if this is our circle over here, and we are wanting to determine the circumference of a circle, which is basically a special word for the perimeter of a circle, the circumference of a circle has its own unique formula. So circumference, such a long word, is equal to 2 times pi times r. That is our formula for the circumference or the outside length of a full circle. So we need to be careful here. This isn't a full circle. This is only half a circle. So to work out the curved half, I would need to work out the circumference and then still divide it by 2. But I would need to use this formula. So just remember, r represents the radius. And the radius is always the length from the center of the circle to the circumference. So in this case, our radius is 3,5 centimeters. So if we go and work out the curved length of this semicircle or hemisphere, you can call it whatever you want, we will go and say the circumference that we're working with, we'll get to the division by 2 in a second, is equal to 2 times pi times the radius, which is 3,5. Now remember, I've said to you that you are welcome to use pi on your calculator, but some of you have been told to use pi as a specific number. So some of you have been told to use pi as 3,14 or 3,142. You do whatever you've been told to do. I use pi on my calculator, but if you've been told to do something, that's what you work with. So if I go and put that in on my calculator, I get 21,9911485. It's a whole long decimal. Now I'm going to keep the decimal because this isn't my final answer yet. But now remember, I want just half a circle. So what I want to do is I want to take this whole value that I've gotten, and I'm not going to write the whole thing again, and I want to divide it by 2, because that's just going to give me the half curved length. So when I divide that by 2, I get 10,9955, and again, a whole long decimal. So that's the length of my curved surface. Now I need to figure out the straight line length. Now remember, the straight line length is from one end of the circle through the center to the other end of the circle, which means I've basically got 2 radii here, or 2 radiuses. And so I've got 3,5 centimeters on both sides. which means that this total length of the straight line is 7 centimeters. And I get 7 centimeters, maybe let's just write that down, by saying 3.5 plus 3.5. And that gives me a total length at the bottom of 7 centimeters. And so now if I want the total perimeter, I need to add the curved surface plus the straight line, which is, oh, these words are so long, 10,9955, blah, 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 plus 7 centimeters. And so when I add this, I end up with a total perimeter of 17,9955 whole long decimal. Right, I'm leaving the decimal there just so that we can quickly chat about rounding. If I told you to round off to 2 decimal places, remember you then go and look at the third decimal. If that third decimal is 5 or more, it needs to increase the second decimal place. Now, because the second decimal place is a 9, that essentially increases to 10, which increases the other 9 to 10, which at the end of the day increases this whole number to 18 centimeters. So just bear in mind when you've got a 9 and then a number in the third decimal place that is 5 or more, it actually ends up rounding off the whole number as well. So our perimeter here is 18 centimeters. Right, I'm going to give you a second to screenshot it. I'm going to give you a second to just think about what we've done. Let me know if you have questions, if it didn't make sense. But essentially it was a half circle here, so we needed to take that into account. Okay, Tando?
Ma'am, I just wanted to find out something. When we're doing circumference and we get the final answer, do we have to write down the entire number or can we just write half of it? Because at school we were told to write half and not the entire thing.
So when you say half, do you mean like only write down like 4 or 5 decimal places?
No, ma'am, like for instance, the 21,9911,4858. And let's say I then end off at 99.
Yeah.
Do we have to write the entire thing or the whole thing?
You're supposed to write the whole thing because that 21,991148 blah blah blah, this is not your final answer yet. Your final answer is only once you've done the rest of the calculations and then gone to 18. So you should write down the whole thing.
So is that then the only time where we don't write the entire thing, but the short way?
Yeah. So the only time we shorten it is in our final answer. You can, however, do what I've done over here and not necessarily write down all the numbers, but use the ... It's showing that there are still decimals, you're just not writing it down. But remember, your calculator stores the answer. So it'll still be on your calculator, you're just not writing it down, which is fine. But like I say, the only time we actually are supposed to round off is our final answer.
Okay.
Okay. Just I see a question in the chat, Batabile, in terms of where we got the 18 came from my rounding off because this was common 995 and then all the rest of the decimals. This third 5 rounds this 9 up to a 10, which rounds this 9 up to a 10. So basically they're both zeros, which bumps the 17 up to an 18. So technically this would be 18,00 centimeters. We don't have to write 00, but because of what the decimals were there, it rounded off to 18 centimeters. I hope that makes sense, but that was essentially from the rounding. Okay, guys, you're doing very well. Well done. So let's have a look at this one before we take a break. Oh, please take your screenshots if you need to take your screenshots. I think I did leave it up, but just in case. Right, let's have a look at B. So question B, I'm asking you once again to determine the perimeter of the shape. So remember, perimeter is the outside length around a specific shape. So we need to know all of the dimensions for this specific shape, just so that this is clear, because looking at this, it might not be. This 3,8 centimeters is sort of the length of the L foot bit. And so we essentially want to ask ourselves, can I work out, no, that was not great. Let me try that again. Can I work out the total length at the bottom? And can I work out the total height down the side? Now we just have to look at the dimensions carefully. So at the top, we've got 3,5 centimeters, which, because this is a rectangle, translates to 3,5 centimeters down there. I then also have 3,8 centimeters along like the foot of my L, which translates to 3,8 centimeters down at the bottom, which means that my total sort of width of this L shape is 3,5 plus 3,8 centimeters, which is 7, something, which is 7,3 centimeters. So the whole sort of width at the bottom, or the whole length at the bottom, is 7,3 centimeters. We can then use the same reasoning to work out the total height. If this height here is 7,3 centimeters, that means on the other side, it is also 7,3 centimeters. And if this tiny little bit at the bottom is 1 centimeter, that then means this tiny little bit at on the other side is also 1 centimeter. And so this total height is 7,3 centimeters plus 1 centimeter, which means we've got a total height of 8,3 centimeters. So I'm going to give you guys a second to try and work out the perimeter of this shape. I've given you all the lengths essentially, so think about how you can work out this total perimeter now. And if and when you have an answer, you can put it on the chat or you can raise your hand. But I want the perimeter of this shape.
My pips, you are doing really, really well. Let's go. Let's try and do it.
And remember, guys, perimeter is the outside length. So if you go all the way along the outside of the L, what is the total length that you're going to cover? Molemo has a little help at the back there. I hope she's helping you, not distracting you. Okay, guys, remember perimeter is if we add all of these lengths around the whole length of this L shape, that is perimeter.
We can do this, my pips. Y'all are doing well. Let's go.
Okay, I'm going to give everyone another minute or so. Again, you're welcome to put answers in the chat or raise your hand. Otherwise, I will go through it in the next minute. Okay, let's have a look. So I'm just going to take all of my scribbles off here so we can start afresh. Right, we've got all of our lengths. So it doesn't really matter where you start, but we need to start adding. So let's start down the whole sort of height of this shape and add what its length is, which is 8,3. So we're doing perimeter is 8,3 centimeters. So that's the first length. The next one is the total length all down the bottom, which is 7,3 centimeters. Then I'm going to go up this little 1 centimeter bit. So I need to add 1 centimeter. I'm going to go along the 3,8 centimeters. I then need to go up the 7,3 centimeters. And finally, I need to add the top little bit, which is 3,5 centimeters. And so, I don't know, that seemed weird. And so by adding all of the numbers together, I have gone around the total outside of the shape. So when I add this all up, I get 31,2 centimeters. And because there were a lot of different answers on the chat, I just want to double check my addition. (31,2 centimeters). So when doing this, guys, what we want to do is we want to add all of the lengths that make up the outside of my shape. And so as long as we are remembering all sides and all lengths, we should be able to get our perimeter. All right, so I'll leave it up there if you want to take a screenshot. And I know that with perimeter, especially in like a complex shape like this, it can get quite confusing with all of these lengths. And so if you need, do like I've done with like a colored pencil or a Koki or a highlighter, as you add your shapes, as you add your sides, just like highlight them or tick them off for yourself so that you know you are including all of the lengths that you need. Okay, perimeter is one of those where we sort of think it's easy, but the more complex a shape gets, the harder it actually becomes. And so we do need to be very, very careful when we do these sorts of questions. Okay, I'm hoping we all got screenshots. I'm going to move on to our brain break now, because you guys have been doing very well. We've done quite a few tough questions here. So I think a break is well deserved. Right, if you need to take a screenshot, don't stress, I can come back. Our brain break's a little different today. And Yolanda actually suggested that we shake it up. So thank you, Yolanda. Today, we've got to guess the phrase. These are, I never knew these were called dingbats, but apparently these are called dingbats. And basically it's a picture that represents like a common phrase.
Whoa.
So we're going to look at these four, and if you want to give a suggestion, you can raise your hand or you can just pop it in the chat. I see Amatle has already got a hand up. Let's hear, Amatle, what do you think?
Ma'am, for number one, I think it's breakfast in bed.
Ah, on it. Ew.
Wow, that fast, Amate. Whoa.
Right, number one, exactly. Breakfast in bed. Almost feel like I might need to zoom in on these a bit, because there's a bowl of cereal in the bed. Molemo, which one do you think?
Ma'am, number three, it's my magnetic field.
Ah, yes, on it. Did your little helper give you that one?
Wow, Mulemo. Wow,
Right,
that's so
exactly.
cool.
Number three, magnetic fields. Well done.
Yes, see, this class is nailing this dingbeds.
I never knew they were called dingbats. Like I've lived my entire 28, almost 29 years of existence, not knowing these were called dingbats. I don't know what I thought they were called, but I did not know they were called that. Oh, are we stuck on 2 and 4, guys? Please don't stress if you find this hard. I find these impossible. Please understand, like I Googled the answers before I put them in here because otherwise I would never get the answers.
Let's think, my people. Let's think. Let's go. Let's go. What do you think, Luyana?
Viola, what do you think? Which one?
I think it's number 4, the one who's doing exercises.
So what do you think the statement is there?
I really can't see. I think the man is jumping.
Yeah, what is he jumping over?
I can't see the picture properly, but I don't know what is that, but because like I can't see the picture properly. So
Okay, English. Yolo is very close. We're getting there. Molemo, do you have one?
Number 4, it's jump Q.
Ah, on it. Well done. So, as Luolo said, the little athlete person is jumping, and if you see there, it's jumping over a Q. So this person is jumping the Q. I don't actually know how you spell Q. I think that's how you spell Q. Luckily, this isn't an English class.
Yeah,
Jumping the
my people are
cube.
really good at this. Yeah. So you see, Molemo, you need to make a sentence, and it's sort of a sentence that everybody uses it. So you know when the phrase of saying jumping the queue, you know, the people are jumping the queue, you're jumping the queue, or you skipping the queue, or whatever it might be. Nice,
Omofara actually sent a message as well of high IQ, which I could actually also see as well because they're jumping high. And so high IQ, I could maybe see that. We've got number 3. Number 3. We don't have number 3. We have number 2 still. It is a hard one.
Number 2.
I'll give you a hint. It's something like science related, biology related. That's my hint to you. Molemo's brain is just like, Aviwe, well done. DNA. Because it's a DNA. Like
well done, Aviwe.
Like
well
pick
done.
and pay, DNA. Well
Yeah,
done.
you did well. You did well, my people.
I love when you guys have your cameras on. It just makes me so happy. Well done, guys. Awesome. You do better than I do at these things. So well done. Okay, let's get back to our measurements. Oh gosh, I made this so big now. Okay. Oh, panic. Right. I have a feeling we've done this question. Can someone remind me? I'm pretty sure we have. Yeah, look at that.
Yes, we have done it.
Yeah, Teacher Sam is not on it. She's going to skip straight on past that. Right. I'm very glad you're all on it. I clearly was not when I did this. Right. Let us have a look at our next question here, which is looking at area. So can someone remind me? You can either raise your hand or you can put it on the chat. What is area? Amatle is on it tonight. Amatle, tell us.
Area is the inside of a shape.
Perfect. Right. So
And
guys,
then the area of a triangle will be half base times height.
oh, on it. On it. Okay. So Amatle has just given us all of our information that we need here. Area is basically the space that a shape takes up. So it's the space inside a shape. And as very correctly stated, if we want the area of a triangle, and I'm just going to be lazy and draw a triangle, our formula is half times base times the height of the triangle. Now, what we need to remember is that the height of the triangle is always measured from the topmost point of the triangle down to the base at a right angle. So that then means that this 10 centimeters is our height. And whatever side it is measured down to and it's perpendicular to or at a right angle to, that is our base. Okay, so those are the two important lengths that we need in a triangle to work out its area. The next thing we just need to remember is that area is always going to be units squared. So when you're working out an area, it will always be in like centimeter squared, millimeter squared, meter squared, etc., etc. But once you've substituted, and you can do that. So because you've got both lengths here, I want you guys to try and find for me the area of this triangle. So you've got the base, you've got the height. I know it already came up in the chat, but see if you yourself can go and work out the area of this triangle. I've written the formula down for you. So all you need to do is substitute in your base and your height. Oh, look at that light. Very nice, guys. I want you to remember area is always units squared. So double check your answers units. I know it's not easy to type that in the chat, but just make sure your actual answer that you've written down is correct. Nice, guys. Okay, so if we have a look here, this would be half times the base length, which is 12 centimeters, times the height, which is 10. Now, obviously, you just put that into your calculator. We don't expect you to do it in your head, but half of 12 is 6. 6 times 10 is 60. So this is 60 centimeters squared. It is an area, so we need to have the units squared in our answer. Okay, very important. If you don't have those units squared, your answer is not talking about an area, so we need to have it there. If it's just a perimeter or a length, no squared. It'll just be centimeters, meters, or whatever. Right, take your screenshot. And then we're going to try this last one. I think this might take us a little bit of time, so we'll have a look. Okay. Right, so we have got this shape. Now, the instructions to this question said determine the area of the following or determine the area of the shaded region. So basically what I'm asking for is I want the area of this gray shaded region. So can someone maybe put up their hand or put it in the chat? How should I go about doing this? I don't want an answer. I just want someone to try and explain to me what I would need to do. You don't have to use numbers, just basically how would I work out the area of the shaded part of this image or the shape. Luyolo, what do you think?
I think you should like calculate the centimeters that are in the what you call it now again? Sorry, because I'm nervous. In the area, and I think you should times the centimeters that are out in the perimeter.
Okay, good. So guys, what we need to be able to do is we need to be able to use the outside lengths that Loyola was talking about now because that's working with the big rectangle, but we also do need to be able to work with our inside measurements as well. Because if I think about this in terms of area, if I work out the area of the whole big rectangle, so A, B, C, D, what I'm doing is I'm working out this total area here, and I'm including that bit in the middle. I don't want to include that bit in the middle. I want to get rid of this area here. And so if I think about that sort of mathematically, if I want to get rid of something, I want to take it away. So I'm going to want to subtract. And so what we want to do, and this is going to be interesting to look at, I want to take the area of the big rectangle, which is A, B, C, D, and I want to subtract the area of the small rectangle. Okay, this is a bit better than I thought it was going to go. E, F, G, H. So if I can work out the big area and subtract the small area, I'm going to get the area of the shaded region. Well done, Luolo. Very nicely explained. Alrighty, guys, so that's essentially what we need to do. So I've sort of given you a hint, well, not a hint, I've sort of given you what we need to go do here. Remember, the area of a rectangle is found by saying the length times the breadth. The length is always the longer side, the breadth is the shorter side. So I'm going to give you 2 minutes to give it a try, and then we'll go through it before you get your quiz link. Remember, this is area, so it needs to be units squared. If you do have an answer, obviously you're welcome to pop it in the chat, or you can put your hand up if you want to explain. Okay, Seatley, do you want to have a go?
Ma'am, I said 14 times 8, which is equal to 112 centimeters squared.
Perfect. Sorry, I just did something silly there. 100 and can I not times 14 times 8, 112 centimeters squared.
Yes.
Okay, sorry, I wasn't listening. Yeah.
And the small square, I said 8 times 6, which is equal to 48 centimeters square.
Good.
Then I said 112 centimeters squared minus 48 centimeters squared, which is equal to 64 centimeters squared.
Excellent. Well done. So guys, that's exactly it. Once we subtract these two, I'm getting the area of the shaded region, which is the 64 centimeters squared. And so what we've done here is we've worked out this shaded area for this diagram. Okay, this is a complex type question. We're expecting you to do some calculations and then go a step further in terms of subtracting. But this is a question that we like to ask. So if it's anything to do with shaded areas, you're probably going to have to subtract something from a bigger area.